All right, so moving on to some more proofs, we are going to prove that a rectangle is a parallelogram. So we are given rectangle ABCD. What we know about rectangles is that these are all 90-degree angles, so we're going to specify that. That's the definition of a rectangle. Now what we know about right angles by the right angle congruence theorem is that all right angles are congruent. So I can say every single one of these angles are congruent. Well, that would mean that I have a pair of opposite angles congruent here and another pair of opposite congruent angles here. So I have two pairs of opposite congruent angles, which means that we are dealing with a parallelogram. So ABCD is a parallelogram because I have two pairs of opposite angles. And sorry, this should say congruent. All right, moving on. We're going to prove that the diagonals are congruent in a rectangle. So we want to prove that BD and AC are congruent. So what we're going to do, I'm going to outline BD in a color. And I'm going to finish off that triangle there. And I'm going to highlight AC in a color, and I'm going to finish off that triangle. These are the two triangles we are going to be proving congruent. Well, A and D are right angles because that's the definition of a rectangle. And if they are right angles, eventually we can say that angle A and D are congruent by the right angle congruence theorem. We'll say that in a moment. We also know that ABCD is a parallelogram because all rectangles are parallelograms. Knowing that information, we can say that AB and CD are congruent because since it's a parallelogram, opposite sides are congruent. We can also say by the reflexive properties, since they both share AD in common, though that's congruent. And then also I said, oops, I missed my step. I will fix this. You guys are going to put a step in here that says angle A and D sorry, that says angle A is congruent to angle D. And that is by the right angle congruence theorem. Make sure that you have that in there. In fact, it might be better if you put that underneath step 2, but it doesn't have to go underneath step 2. So then these, so angle A is congruent to angle D. So these two triangles are congruent by SAS. Since they are congruent by SAS, that means that BD and AC can be congruent by CPCTC. All right, moving on to the next proof. We're proving that a rhombus is a parallelogram. So we're given rhombus ABCD. Knowing that it's a rhombus, we can say that all four sides are congruent to each other, which means that I have one pair of opposite sides congruent here, and I have another pair of opposite sides congruent here. So I have two pairs of opposite sides congruent, which means that it is a parallelogram. All right, and then moving on to our last proof in this video. I'm going to prove that one diagonal bisects the angles in the kite. So we have kite line here. We're going to prove that LO bisects angle L, so cuts this angle in half. Knowing that it's a kite, we can say that LI and LN are congruent. We can also say IO and NO are congruent. We can also, in these two triangles, say that LO is congruent to itself by the reflexive property. So then I can say that these two triangles are congruent by SSS, which means I can say angle 1 and angle 2 are congruent by CPCTC. That does not prove that LO bisects angle L. We would then need to say LO bisects angle L, because that's the definition of bisects. Since these two angles are congruent, then we can say that LO bisects that angle. All right, that's the last proof in this video.